Welcome to Math Challenge 461. Math Challenge for all quantitative and numerical aptitude tests for school exams, junior and senior Olympiads, and competitive examinations. In Math Challenge 461, we are given a quadrant and a rectangle. You can see the quadrant, the center is O, and a rectangle ABCO. And the distances CX and AY. And we have to find the radius. The radius is OX and the radius is OY. We have to find the radius of the quadrant. The quadrant, inside it we have a rectangle, and we have to find the radius of the quadrant. Math Challenge 461. Now look at the figure. OY is the radius. O is the center of the quadrant, so OY is the radius, and AY is 2, so OA will be R minus 2. And because this is a rectangle, CB will also be equal to R minus 2. And see this, OX. OX is the radius R, and CX is 9, so OC will be R minus 9. So in this rectangle, we get OC is R minus 9, and CB, which is equal to OA, is R minus 2. So we get the width and height of the rectangle. The width of the rectangle is R minus 9, and height of the rectangle is R minus 2. Now draw the diagonal OB, the diagonal of the square. We draw OB. So this is the radius. OB is also the radius joining the center and a point on the arc, that is circumference. So OB is the radius and also the diagonal of the rectangle. So draw radius OB, which is equal to R radius. Now the triangle BOC is right angled. We get a right angle triangle because BC is perpendicular to OX. So we get a right angle triangle, that is triangle BOC. What we are doing? We are joining OB, which is the diagonal of the rectangle and also the radius of the quadrant. So the radius OB will be equal to R, and BOC is now a right angle triangle. Now look at the blinking right angle triangle. In the blinking right angle triangle, the hypotenuse OB is equal to R, that is the radius. The hypotenuse OB is the radius R. The altitude CB is R minus 2, and the base is R minus 9. We get a right angle triangle. You can see the right angle triangle blinking. The blinking right angle triangle is shaded pink. The hypotenuse is OB, which is equal to R radius. The altitude, the height of the rectangle, is R minus 2, and the base, which is the width of the rectangle, is R minus 9. So using Pythagoras theorem, hypotenuse square should be equal to altitude square plus base square. So R square is equal to R minus 2 whole square plus R minus 9 whole square, or R square equal to, we expand this, R minus 2 whole square, that is R square minus 4R plus 4, and also expand this one, R minus 9 whole square, R square minus 18R plus 81. So R square and R square will cancel. One R square will cancel from the right side, and R square on the left side will cancel with that. So 0 equal to 1 R square is cancelled, so 1 R square remains. R square minus 4 and 18, so minus 22R plus 85, 4 and 81. So we get 0 equal to R square minus 22R plus 85, which can be factorized as R minus 5 into R minus 17. Now we take R minus 17 equal to 0, that is R equal to 17. R equal to 5 is rejected because See the OX. It has to be greater than 9. A part of it is given as 9. CX is given as 9. So OX has to be greater than 9. So R equal to 5, we reject that because we know the radius is greater than 9. OX is greater than 9. CX is 9. So OX will be longer than 9. So reject R equal to 5 and we get R equal to 17. That means the radius of the quadrant is 17 units. So from the right angle triangle, we apply Pythagoras theorem and ultimately we get two values, R equal to 5 or R equal to 17. We reject R equal to 5 because OX must be greater than 9. So we take R equal to 17. So the radius of the quadrant is 17 units.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.